Right. Good morning, everyone. I am excited to get us started in the sixth installment, but the fifth mathematical practice in the
Mhm.
10-part webinar series on the eight mathematical practices. Today, we're going to talk about Math Practice 5. My name is Sara. I'm the MDE Academic Standards Specialist, and I'm excited to be up early this morning. As a reminder, all the webinars in the webinar series are being recorded. Several of them are already up on MCTM's YouTube channel. In the chat, you will see links that link you to the documents connected to this particular training, as well as getting you connected to all of the rest. The overall link that I'll share at the end connects you to all of the video links, the session folders. In fact, it's the document most of you got here to the webinar. It's where the Zoom link is. If you scroll down, you will see this table. And I put a new column in there called Toolkit. I've been making toolkits, but a lot of people haven't found them. And so I cited those specifically. When you get there, it gives you a professional learning protocol of how to use the videos that I'm uploading. All the ones I'm behind on, I'll get uploaded this week. And it also gives you links and resources to study, including that toolkit. So all of the webinars in this webinar series I'm working on one of the 10 points at MDE's commitment to equity, specifically around improving the conditions for K-12 students in Minnesota and their conditions for learning. I've really tried to center the future of the students that our world students will live in. In fact, last night I was going down a rabbit hole of learning about what's coming next in the area of tools, artificial superintelligence. They say that the world is going to change pretty radically as soon as 2030, but 2035 at the latest in the next iteration of where AI is going. And so I was thinking about how that changes education. And I'll talk about that as part of this series because really the goal of this series is how do we, the adults in the system, create the conditions for our students to engage in these practices, because these are the practices that will allow them to thrive in a world that is changing and will look different than the world that I was brought up in. There are some evidence of the world that they will live in. I've shared this slide a lot of times, but today I just want to highlight some words that are really going to be connected to this particular practice. When we think about tools, we'll be thinking about that word in a lot of different lenses. All of this is part of the proposed 2022 Minnesota math standards. And in those standards, there are two dimensions that overlay all the work of every single benchmark and standard. One of those dimensions I'm doing a lot of professional development on this year. It's the math practices. At the end of this series, we'll talk about how you can implement all the things that I've been sharing with you. Next year, we'll be looking at dimension 2 as we're doing these. So the math practices, this is another slide I'll share every time. They describe the varieties of experience that us as the math educators at all levels should seek to develop in our students. So today we're looking at Math Practice 5. Super excited. Every time I do one of these, it's my new favorite math practice. Math Practice 5 is one of the 4 practices that are considered the tools of the math practices. Math Practice 1 is the goal that our students are able to make sense of problems and persevere in solving them. There are 3 drivers of this, but today we're going to look at one of the 4 tools. If you want to read in depth about it, you scroll to the end of our proposed standards and there's paragraphs that describe them. I am sharing a copy of my slides. It's already in the folders that I've shared with you. And you can take a look at what's going on there as well. So today, Math Practice 5 reads as use appropriate tools strategically. And 2 words in that statement stuck out to me that I'm going to frame this short webinar on. The first of those words is tools. The second one is strategic. And I'm going to frame how we're going to think about this with 3 questions. And those are 3 questions that are just questions that pop into their minds of students. Hey, I'm sitting in a classroom. What do I have helpful to me to help me make sense of mathematics, what tools are available. And then if I do know what tools are available, how do I know to use those tools? Like you're assuming I know how to use a ruler. I don't know how to use a ruler. You're assuming I know how to use AI appropriately. I don't know how. Do I know how to strategically select tools? Different tools are appropriate for different situations. And so as we're thinking about this, we are going to be looking at three questions, one being what tools are available in the math classroom? What is the tool for? Why are these tools available and how can we use it in math and which tool is best for this math task? So let's get started with that first question. Students ask, we know that Math Practice 5 calls to us for that they're to have experience with a wide range of tools in mathematics. So let's define what we mean by math tools. So I would love a few people to put some things in the chat. One, it lets me know if you're awake this morning. This is a picture of my mom. She's 79 years old. It's a picture from a week ago. And my youngest nephew, who's 9. Do you see any tools in this picture? They don't necessarily have to be math tools. Do you see any tools anywhere in this picture at my mom's house, my dad's house? Any tools that you see? Ooh, we see a cup. The cup is going to get coffee into our mouth. Yep, that is a tool. Ooh, Jane, you know what my nephew is holding? We were making lefse that day. He has a lefse stick, a lefse flipper. We got some Scandinavians in the crowd here. Yeah, there's a lamp that sheds light onto the things around there. So we know that tools are not just things that are found in a toolbox, a hammer, and those other things. So when we think about a math classroom, I want to give you a few pictures and I want you to start thinking about what are math tools. Here's some students working. Here's some other students working. When we think about math tools, what are math tools? Oh, by the way, I love all the things you put in the chat related to my mom and my nephew. You guys saw glasses. And then there was tools you didn't see, like my mom is deaf in one ear, and so you couldn't see her hearing aids that help her hear. So here's the definition that Robert Kaplinsky shares of what a math tool is. It's any resource. So today, when you're thinking about this math practice, I want you to think about a tool being any resource or method that can be used to solve a math problem. So when we're supporting students and using tools appropriately and strategically, that's anything in our classroom that's a resource, something you can physically touch, or a method that can be used to solve a math problem. And so the word tool even shows up lots if you search that word in our standards. It shows up, for example, in Anchor Standard 3. That's the measurement tool, and it says investigate measurement using a variety of tools. And then if you look at the benchmarks, there's more specifics on that. I think sometimes the obvious tools in math are things like rulers, but we're going to look at 4 types of tools and what those tools are as we're looking at them. Robert Kaplinsky has defined these with a few examples, but I made some pictures so you can see some examples. So let's start with physical tools. Physical tools are probably the easiest for people to imagine in a math classroom. They're things people use in real life to do math, things that we use in the classroom. There's things in that picture people don't always think of as tools, but to do math and think about solving math problems and reasoning with math, we use erasers and pencils and all kinds of things to do. That includes paper, graph paper, like I said, erasers, pens, pencils, and all those things. It also includes all the physical manipulatives that we find in classrooms. I had shelves in my last classroom. You can actually go to my blog, and I videotaped my whole classroom, and I had a wall of supplies students could access anytime that included tools that they could access when they needed them. So when we look at this picture, there's some physical tools that I see. I'd love for you to throw things in the chat. Some of you already have. Somebody said a whiteboard is a physical tool. Absolutely. The student has pens, whiteboard pens, and calculators in their hand. Thank you. Yeah, there's a clip holding up the paper in order for them to make sense of the task that they're working on. And all of those things are tools. So when we think about what maybe they're using those tools sitting in their desks and tables tables. A calculator is a form of a physical tool. If you're in the younger grades, this is one that gets used a lot in a lot of classrooms. Super, super powerful at Rec and Rec. I just had to include the picture because I like saying Rec and Rec when we're doing it. If you go to Target, in the fall, you can buy a set of physical tools. It often looks like this. I don't know how many of you have used the triangle tools, like in your classroom to measure things. They feel like drafting materials to me more than math materials, but like these are tools of the classroom. I found somebody who had collected across the grade levels examples in different some of the different strands of math of different tools that would show up within that. Spreadsheets can also be a physical tool, but this starts to delve into a different type of tool. And so we're going to look now at another type of tool, which is all this virtual and software tools. Pretty much all the manipulatives have an online version. One of my favorite places, because it's free, is Amplify's Polypad. Their tools at their site are lovely because you can literally do some really cool things with them. For example, I love the pan balance where you can solve equations on Polypad and the pan balance goes up and down as you manipulate the variables and do things with it and add things to the pan. And you're really showing and making concrete, which is what's in that video. And so in my classroom, when I was teaching, used a combination of both physical tools. I think sometimes it's really important for us to touch things, but also virtual manipulative tools. Amplify is not the only site. There's many, many sites. In the resources I shared with you, in the thing, there's a ton of links to a lot of different sites that have virtual software tools. I just put that link in the chat. If you're watching this webinar virtually, check out the links in the description. They will get you to all the links where I've shared things. A lot of people in Minnesota use a lot of the free manipulatives, especially at K5 at the Math Learning Center. They have a ton of apps. If you are a fan of Rec and Recs like I are, and you scroll down on this page, you'll find one there. Terry Weiberg from the University of Minnesota blew my mind when he was using it to explain something to me about a month ago. And so there's all kinds of tools. Another favorite of mine when I was teaching secondary math was all the things at Desmos. This is just the Desmos calculator, but there's a whole teaching, teacher Desmos and free tools that you can use there. GeoGebra has a ton of tools. And then I'm going to talk about two that are kind of controversial in mathematics. That's Wolfram Alpha and Photomath and all the other things like them. In math, we've had AI for a long time before AI got popular in the last couple of years ago. And I just wanted to name this because there's a lot of teachers who are still not using a lot of the tools that our students use all the time. So I'm going to talk about the paradigm shift I've had in my math teaching. Literally all of these tools existed when I started teaching. They were there, like in the school, you could still find a film, a way to show films this way. Even 10, 15 years into my career, some of these tools were the only tools we had to do things. I didn't have a computer in my classroom until maybe my 8th year of teaching, 10th year of teaching. When 9/11 happened, about 10, 11 years into my teaching, we rolled a big cart with a huge TV on it into classrooms so students could watch what was happening in the world. We did not have cable at that time. I didn't even have a phone in my classroom the first several years. I went to college with a typewriter. And the reason I'm telling you all this is I have shifted how I have taught mathematics over those years. Somewhere in the beginning of my career, all these calculators started coming out that could do fractions and could do math in different ways. So as these tools came out, it shifted what I taught, how I taught, what I assigned as homework. Phone came out in my teaching career. At the end of my time in the classroom, I wrote about how this was a tool for 5 specific things. I allowed phones in my high school classroom. Desmos was a game changer for me. It was an online phone that students had with them 24/7 when their graphing calculator that they owned was sitting in their book bag on their bed several miles away from them, but they always had a calculator with them. 10, 15 years ago, photo math came out and it really changed what I assigned as homework. I told students about it and said, go ahead and use it. I know it exists. And I just changed how and what I valued. And in the last couple of years, open AI has come, and a lot of people have been freaking out about this. But really, the world hasn't changed. We think those things are allowing students to cheat. But prior to those things, parents were doing their homework for them. We've never known when students are doing things outside of school who's doing it or what's doing it. And so tools are not the scary part. It's how we in the system react to those tools. There's also self-created tools. Those are things that students create. They create things to answer questions like, hey, how am I going to organize this data? Is my answer reasonable? And so self-created tools are not things we think about all the time, but they're tables that students create to put together data. That is a tool. It is all their estimation skills. Probably the most underrated thing that we don't spend enough time in developing in students is the tool of estimating before they calculate on their calculate, estimating what they believe the answer would be, because reasonableness is a skill that they will have in life as they're going. I think there's somebody who's not on mute, so I'm just going to quickly pause the video because there's some kind of clicking that is going around. I'm just going to see quick if I can figure out where it's coming from, and I'll cut this part out of the video. Thanks, you guys. And there we go. Okay. And so estimation, I'm going to pause so I can cut this out of the video with my limited editing. All right. Hey, you guys. So estimation is really an underrated skill. Having students develop that is a tool that is going to help them with all the physical tools. Another self-created tool are generalizations that students write, equations to help them answer other things. We don't think of, for example, the Pythagorean theorem as a tool, but it is one of the tools that students have in their toolkit to help them solve problems. Also things like double number lines and ratio tables. Those are self-created tools to help them make sense of math and solve problems. And often spreadsheets fit in this category as well because we use them to organize data. We use the sum feature on them to calculate things. They are tools. Another type of tool is conceptual tools. Those are all the things that we use also to help us make sense of the concepts that go along with that as well. So let's go to question R2. Math Practice 5 calls for us to not only have all those tools, I named all kinds and it wasn't even an exhaustive list, but we also have to know how to use them. So I want to spend a few minutes on something that a lot of times I overlooked in the early part of my career is I just assumed students would know how to use these because we were using them in class, and it turns out they didn't. And I'm going to give you an example, two examples. One is with a calculator. In my classroom, I had a classroom set of TI-84s, and I spent, before I started doing what I'm going to tell you next, I answered thousands and thousands of questions every single day on Miss Van, how do I do blank on my calculator? It's just like they were helpless. And so when I started teaching the tool before I let them use it, one way that I taught them is in the second day of class, we talked about the top 10 things you need to know on the TI-80 graphing calculator, and we modeled how to do those things. We all practiced it together. They took notes on it. We made an anchor chart of it. So every time students ask me anything about these, by the way, these represent their top 10 questions, all these questions went away because I just pointed to the anchor chart and they could solve that problem for themselves. When the Desmos came out, then my teaching of the TI-84 was done simultaneously with the teaching of Desmos. So they were doing all these things on both of those tools. in those 10 problems that you see in this one, those are the 10 things they enter wrong into their calculator all the time. For example, in number 4, students always confuse on calculators the difference between a negative sign on the calculator, finding the inverse of a number, and subtracting things. There's a lot of things that when you teach them how to do it and they take notes and then they tape this into the inside of their notebooks, a lot of your problems go away. Probably the biggest revolutionary game changer in my classroom is when I started thinking of Google as a tool. In fact, it was the most used tool when I last was teaching in the classroom. It's the tool I use as an adult, probably one of the most. And I taught them how to think about Googling to solve all their problems in math. I decided probably 10 years ago to stop answering any questions that they could answer for themselves. And it was around 10 or 12 years ago, because it's when I first got, my students had one-to-one devices in the classroom. They had iPads. And so when I said, I'm going to get out of the business of answering all their questions, because I'm not at home with them when they're trying to do work outside of school, I'm not going to go to their next year of math with them. And so one day we were doing a problem something like this, and we had been talking about how to find the angles in a triangle in a unit 2 months ago. And some student asked me, hey, how many degrees are in angle C? And I was like, great question. Everybody in the class, let's get out our device. Let's use our device to help do this. And then I walked around to see how they were trying to solve this on their device. And they had opened up a search engine, and about half the kids had typed the word math into their search engine to try and solve this problem. I don't know if you've ever typed math into a search engine to solve this problem. And I was like, wow, they don't know how to use Google. They don't know how to use Google to solve math problems. If you Google math, there is very little about triangles and degrees that you can find, and kids get frustrated. By the way, pro tip, the best way to use Google quickly with students is to teach them to click on images. Most of the answers to their questions are found in Google Images. So then I said, is there a better word that we could do? And we were working together to learn how to use Google as a tool. And some kids said, oh, I see the word degree. So we tried Googling degrees. Oop, that didn't work super well either. We got a whole bunch of stuff that didn't have anything to do with math. So we went back to the problem, and a kid said, let's do degree and math. By the way, pro tip, if you just put the word math with any other mathy word, it improves the Google search a lot. It still didn't get us where we were going. So we went back and looked at it one more time, and the student said, hey, I see a triangle. I said, hey, let's try Googling degree, math, and triangles. What do you know? Here's what happened when students saw this on their iPads, their computers, their phones. All of a sudden, students shouted out, oh, I remember how to do this. And I was out of the business of answering questions because Google Images could remind them of things that they had learned to do. If the pictures didn't help them, it usually helped their friend who was sitting next to them. And they're like, oh, I know how to show you how to do that. But 2 seconds ago, without those images, they wouldn't have been able to support their friend in doing this. When I taught my students how to use Google, 95% of my questions went away in the classroom. And all of a sudden, my homework percentages increased radically because all of a sudden they knew how to solve their problems without me. Now, it didn't happen overnight. I did have to practice in classroom. I would, anytime a question was answered, I'd pull up my search engine on screen and I would Google in front of them. Anytime we were doing a problem in class, we would practice during the first fourth of the school year, coming up with phrases of how to Google things. So we would be adding fractions, and I'm like, hey, what's a phrase that we could type into Google to remind us how to do this? And so they would say something like adding fractions, and then they would throw the word math in there. And sure enough, there were things that would show up that would support them in learning that. I started putting on assignments, Google phrases that I had tested out myself. And then I took that scaffolding and support away during the second quarter of the year, and they started to do things. I also started using Google as a way of reviewing prior things. This is from my Algebra 2 class. They had learned about quadratics and intermediate algebra. So on the first day of the Algebra 2 quadratics unit, I gave every group of 2 students one piece of blank paper, and I said, get out your phones and your computers and Google everything you know about quadratics and write down all the things you know. So rather than me telling them the things they should remember, they were using tools and with partners in conjunction. By that way, that 2-to-1 ratio is super important to do that. So all these physical tools, online tools, like a ruler, don't assume your students know how to use a ruler. All of these things we have to teach them. Don't assume that they know how to make their thinking visible. Showing them what you mean by that phrase, making your thinking visible, increases that a lot. Third thing that I want to remind you of is that Math Practice 5 calls for us to be strategic in the use of tools. And as we're thinking about the tools and being strategic, I want to show you a drawing that Ben Orland made for Minnesota for this particular practice. So throw in the chat, what do you notice and what do you wonder about the picture Ben drew to go along with this particular practice? What do you notice about it? You can notice anything, including that this is a guy that's blue. Our guy is blue. I particularly like his eyeballs and stuff. But what's something you notice about this? If you're watching the recording, say something you notice out loud, interact with it. Oh, if you have a hammer, everything is a nail. I love that. Thank you. Yeah, 2 different tools used in 2 different situations. Talking of situations, I thought of 3 situations that we might use one of these tools for. So like if we do have a nail, one of these tools make more sense. In fact, look at his eyeballs. He's looking at his hammer and he's like, that hammer looks like a better tool than my spatula over here for doing this. And so he's going to go and tackle that particular hammer with that tool. But if I'm trying to fry an egg, I could use that hammer to like stir the egg, but you know what might be nicer? To use the spatula. So now our guy is going to flip his eyeballs over to that spatula and be like, dude, if I'm going to flip that egg, that spatula is probably going to do a better job than that hammer. But I used AI to say, hey, what's something that you need that a hammer and spatula are equally good at? And AI told me opening a jar of pickles where the jar lid is super tight. You can use the spatula to go under the lid and like try and loosen it that way, or you can use the crow, like those little sharp points of the hammer to pry it open. And in that case, the eyeballs of our guy could go in either direction. So MP5 is us using tools and using them strategically. And remember, tools are any resource or method that can be used to solve a math problem. Don't assume students know how to use a Pythagorean theorem. It's on us to give them experiences so they know when and how to use that. What Ben said about his drawing is he says, when using a math tool, make sure it's the right one for the job. You wouldn't flip a pancake with a hammer or drive a nail with a spatula. So pro tip, offer students only a couple of tools, 2 or 3 at the most, especially in the first half of the school year. If they have a whole universe of options to be strategic with, they'll never be strategic. If you only give them one tool and say, use this tool, they don't develop the ability to be strategic. So offering students just a couple of tools to choose from between and saying, why is one better than the other? Is a great thing to do. So I'm going to close with a few kind of closing thoughts on this. One is just a silly thing. A teacher posted that they'd gone to the store because they were going to make donuts and they had a whole lot of oil and flour, and their wife was making fun of them, like literally, how many donuts are you going to do? Another math leader was like, hey, this would be a great task for students to figure out how many donuts you can make with this. And Curtis said, great idea, but I cheated and I went to Alexa and I asked Alexa, and the math leader said back, that's not cheating. It's called using Math Practice 5, using appropriate tools strategically. So I want to remind you that our students live in a world where these tools are there. You named some tools in my mom and my nephew, but there's a few tools that you don't see as obviously in there. My mom has a smartwatch on her arm. She has a phone in her pocket. There are Alexas everywhere in this picture. My mom uses her phone and her watch every day to do all kinds of things using that tool. She often loses her phone, so she'll say, Siri, to her watch, ping my phone, and her phone is ping, Siri, open the music app. My nephew, I was watching football, the Vikings with my nephews, and throughout the game, in a really lovely way, they were using Alexa, Alexa, which Vikings player has the most rushing yards? And then they would discuss it amongst themselves, and then they'd ask another question that was built off of that. And so our tools are there to support us. And so when we think about photomath and all those things, I want to put this as one of our final statements, that this isn't about being afraid of these tools. If we're going to support students in using appropriate tools strategically, I wonder how we redesign our math classes to utilize these tools, or ask questions that require more complex and creative thinking. If we live in the land of photomath, then we need to just be okay with that, because I can go to my watch to this day. Well, my watch is right here. And I can say on my watch, any arithmetic problem I want. Our students will have those tools with them. And so we need to stop teaching them to do things without the tools. Stop taking calculators away most of the time. So last thing, oh, Siri and Alexa are trying to say things to me right now. Last thing I want to talk about is, how do we redesign our practice? Well, I've given you some pro tips, but one of the things is really having students practicing using these tools in relationship with one another. Use the 2-to-1 ratio. We want students centering reasoning and reflection with the tools. And so if they're isolated, only using their tool, that's almost never the way I have them use any tool, whether it's a physical tool or an online tool. I am always 2 devices to 1, 90% of the time. When we think about tools, we're using physical tools, but then we want to create the conditions for students to ask for other things. This teacher talked about how their students in the younger grades were organizing beads into cents of 10, and they asked for 10 frames to help them, and the teacher had it ready, tools that they could bring in. There are lots of resources out there, and I've linked to lots of ones that say the use of how we use tools is linked to what our learning intentions are. And so there's lots of examples of how we would use this, how this is related to the intended learning. All of these tools are tools we should be learning, because it's just like 6-10 years away when the world is going to have another significant change in the jobs our students will have and doing things with super intelligence, and who knows what comes after that. I've also linked to some free modules from one of my favorite people, Jennifer Sue, who did a lot of work and research. She works at a university around thinking about technology and how that relates to the math classroom. So if you're interested in that, there's a whole framework that you and your staff can engage in to do that. I've linked to that. I've also linked to people who are pushing back. I love the work of Davis, and Davis is saying, hey, we should rewrite SMP5, because we should also include developing new tools and using them creatively, because that's what our students are doing. That's what Rene Descartes did. Rene Descartes, when they were thinking about math, were thinking about, I'm going to need a coordinate grid in order to make sense of these ideas. And so math is created, and that includes our students in their future. So here's the summary. We have students, mathematicians, who are going to use appropriate tools to make good decisions about which tool to use, to visualize, analyze, and help solve problems. That's what tools are for. To identify and pose and solve problems, and then use estimation. I could do a whole nother 3-hour webinar on estimation to detect errors. I can't undersell how important building estimation in to what you're doing is. And then that's on us as the teachers to do it. So here are the things we are going to do. Support students in understanding why we use things. Make sure that the tools are always available. I just kept calculators at their desks 100% of the time. Frequently model the use of those tools, and then give them a choice of materials. I recommended 2 or 3, and then talk about which one we're using and why, kind of like the hammer and the spatula. So a tool is any resource or method that can be used to solve a math problem. The 3 questions I framed this from were, what tools do we have? how are those tools used? How do I support them in using them? And how do we become strategic? Which tool is best? So that was Math Practice 5. Everything that I've talked about today is already linked. It says coming soon, but I already have it linked. This bit.ly or this QR code, I will throw into the chat one more time the link to all of the things I shared. Again, if you're watching this webinar, you can check out in the description the links that I am sharing with the people that are listening live. If you're listening live, I'll stick around for a few minutes to answer questions if anybody has a few questions. And yeah, if you go to these resources, don't sleep on the toolkit. The toolkit is amazing. The next webinar will be in January next year, 2025, January 8th, and we'll be looking at the one I'm kind of the most excited about. I just love this idea of attending to precision. That's the one I have the most stuff on. I don't know how I'll get it down to a half hour. But yeah, we're closing in on the end. And so, like I said, I'm going to stick around and answer questions. Last thing I'll show the people who are watching the video, and then I'll cut the video off, is I used AI to write a haiku for Math Practice 5. So I'll just land this here and we'll end on this screen. I used one of my tools, AI, ChatGPT, to write a haiku connected to Math Practice 5. So amazing. Have a great day, everyone, and we'll see you at the next webinar.